Hello students, welcome to the session. Now in this session we are going to discuss about GATE 2024 paper PI questions. So in the last session we have seen industrial engineering questions. Now in this session we are going to see that production questions, that is manufacturing questions. So whatever the things we have been discussed in the class, so the same is going to be discussed in this. That means what kind of questions are coming, that solutions, how to solve. I will tell you some simple techniques. However, most of the questions we have solved in the class, but we will see in this session as well. Now, let us come to the section B in manufacturing and production engineering. Okay, in that, how many questions are came and what are the marks? I would just like to highlight. Right, have a look on this here, guys. So 1 mark questions. So 1 mark questions are 8 came for 2024 PI paper, 8 marks. Now 2 marks questions came 13, right? So now here 13 into 2, 26. 26 plus 8, 34 marks. Total manufacturing, you got 34 marks in PI paper. Okay. So more weightage for industrial engineering as well as the production. Okay. Industrial engineering means I am and over. What are the topics we have been discussed that are right. Now let us see today manufacturing questions. I have segregated that 2024 paper PI manufacturing questions. Right. Have a look on this first question. Question number 15. It is a multiple choice question. Right. Now let me read the question. The solidification time of cube and cylinder of the same material produced to the same sand casting process. Right. What is that? A cube and cylinder casting with the same material, with the same casting conditions, they casted. And it is found that equal. That means the solidification time of cube and solidification time of cylinder both are equal. Right. Each side of the cube is A. Right. Next, and the radius of the radius and the length of the cylinder is R and 4R. Right. Now here, respectively, if solidification time is governed by Chernoby's rule equation, then what is the ratio of R by A? This is what we need to find, right, guys? Right. Now, for this, I would like to have a small diagram, right? Now, this is a square. This is square, and they said that square side is, that means cube. Cube side is A. So this side is A. And similarly, there is a cylinder. There is a cylinder. Now, this cylinder height is 4R. So that is equal to, we can say it is a H. Right. Now here, its diameter D is equal to 2R. That means radius, they mention the radius and the length of the cylinder R. So radius of the cylinder is R. Then diameter is equal to 2R. Now what they are telling? So the solidification time of cube and cylinder is equal. Is found to be equal. That means solidification time of cylinder and solidification time of cube both are equal, right? So what is a formula that we had been discussed for this is that, what is the formula? Solidification time is equal to, it is volume by surface area whole square into K, right? So K is constant for both cases, right? Now this is for cube solidification time, and solidification time for cylinder is also volume by surface area to the square into K, right? K is constant because why? Because it is the same material and also same casting process, right? That is same conditions. That is why K in both cases are equal. So we can neglect the K. Now what they are telling, so the solidification time of cube equal to solidification time of cylinder, right? Solidification time of cube is equal to solidification time of cylinder. So first we'll try to find out the solidification time of cube individually, solidification time of cylinder individually. Later, we just equate that, then we will find the relation between the R and A. Okay. So what we need to find? We need to find relation between the R and R by R upon A relation we need to find. Let us move for that. Right. Solidification time of cube first. Solidification time of cube. It is equal to, it is volume by surface area whole square. So what is volume of cube a cube, and surface area equal to 6a square whole square, isn't it, guys? Right. Now from here I can write it is, a cube will get cancelled, a by 6 whole square. Clear, everybody? Right. Now it's a surface area 6a square, and cube volume is a cube. That is what I substituted. Now let's move that solidification time of cylinder. So volume by surface area whole square. All right. Now volume. What is the volume? Volume of cylinder pi by 4 d square into h, and is divided by surface area. So now top surface area pi by 4 d square, bottom surface area pi by 4 d square, and this fellow is pi dh surface. So this will be pi by 4 d square. This will be pi by 4 d square. Right. Now pi by 4 d square plus pi dh plus pi by 4 d square. So the total what happened? It is going to be a 2 pi by 4 d square plus pi dh. Right. Now as we know that h equal to 4r and d equal to 2r. Just substitute that. Right. Now if you substitute that, then pi by 4 d square is 2r whole square into h is 4r, and is divided by pi by 4, 2 pi by 4, 2 by 4 d square, 2r square plus pi into d is 2r plus h into 4r. All right, guys. Now you just take pi by 4 out. So pi by 4, if I take out such that what happened? It is going to be a 8r cube. It is going to be a 8r cube. Similarly, here also, if you take that pi by 4 out such that 2 into 2r square plus 2 into 2r square plus, now pi by 4 if it goes, then it is going to be a 4 into 2r into 4r. So 8r square I'll write. 8r square I'll write. Clear, everybody? Now pi by 4 will get cancelled. What is the remaining terms? 8r cube. Right. Now here it is going to be a 8r cube and is divided by 2 into 2 4r square, and 4 into 8 32r square. 4r square plus 32r square. 4r square plus 32r square, such that I can write it is 8r cube is divided by 36r square. Right. Now here I can write it is 8 by 36 into r. Clear, everybody? 8 by 36 into r. Oh my god. Here, guys, we have done small mistake here. Have a look on this here. 2r square. What happened to r square? 2r square is equal to, it is going to be a 4r square. It's going to be a 4r square. So that 4 into 2, 8r square plus 32r square. Right. Now here, eight r square plus 32r square. Now here I just clear all this. Guys, while you're doing calculations and do it properly. Okay. Right. Now 8r square and is divided by 8r cube, guys. 8r cube is divided by 8 plus 32, 40 r square, such that I can write it is it is 4 somewhere we did again mistake. Yeah, here also it is gonna be a not 8r square, guys. 4 into 4 here. Okay, guys, I'm sorry, small mistake. Right. So pi by 4 I'll take out such that 2r square. What happened? 2r square whole square na? So 4r square into 4r. Right. Now it is going to be a 16r cube. It's going to be a 16r cube. Now it is going to be a 16r cube and is divided by 8r square plus 32r square, such that I can write it is 16r cube and is divided by 40r square, so that uh, 8 2's 8 5's, such that 2 by 5 r to the power whole square. Why? Because here this is all whole square. All right. Now here also it is a square. Whole square. Clear, everybody? I hope you understand. I hope you understand. Right. Now solidification time of cube is a by 6 whole square, and solidification time of cylinder is 2 by 5 r to the power square. Right. Now, according to the problem, what is the data? According to problem data, so solidification time of cube is equal to solidification time of cylinder. All right. So solidification time of cube is a by 6 whole square, and solidification time of cylinder is 2 by 5 r to the square. Now here it is going to be a square by 36. Then here I can write it is 4r square by 25. Clear, everybody, guys? Now what we need to find? We need to find r by a, right? R by a. So that's the reason why here what I do is right. There I'll go with the r square by a square is equal to, is gonna be a 25 by 36 and is into 4. Yes, guys, right? 25 for this side and r square come this side. Right now here I require r by a, such that it is gonna be a 25 is divided by 36 into 4 under root. Now here, so 36 into 4 is equal to, it is going to be a 144 under root. So that here I can get it is a 5 by 12. So my r by a relation is 5 by 12. Right now let us move for where is answer. Now 5 by 12 is my answer, so that this is my answer. So answer is B. So it is a 2 marks gate question, guys. Okay, now this is what answer. Okay, hope you understand. Nothing is there. You just find the solidification time of cube individually, find the solidification time of cylinder individually. So individually I calculate the solidification time of cube is this much. Now solidification time of cylinder is this much. So according to the problem, what they said that it is that the solidification time is equal. That is the reason why here I just equate both the and then find out the relation between the r by a. I got this much. Hope you understand, guys. Hope you understand. Please do respond. Right. Good. Very good. All right. Now let us move for the next question. Right. Have a look on this question, guys. Right. Now match the following, and then another 2 marks question, and match the listed defects in the deep drawing cup. Deep drawing operation we had been discussed, right, with a corresponding reason in the table. Right now here, let us see that orange peel on the surface of the cup. So when it is going to be orange peel, right? Now when this is the defects and these are the reasons, right? Now wrinkling at the flange of the cup, obviously whenever you're not going to be produce the blank holding force, BHF, right? This we call it as BHF. Go to our note so that you will find this. So whenever if you're not providing this, then wrinkling defect is going to be happen, so that we know that Q is 1. Right. Next, P, just eliminate that. Right. Next, tearing at the bottom of the corner of the cup. That means whenever cup is like this. So when the cracks are going to be formed, whenever you're not providing or very small corner radius leads that there is a tearing at the bottom of the corner of the cup. So here cracks are going to be produced because of the less corner radius. Clear everybody? Clear everybody? Right. Now that's the reason why here. So R is going to be 2. Are going to be 2, right? Earing up the top of the edge of the cup. Obviously, anisotropy of the blank of the material, right? Now, here it is going to be a 4, right? Now, obviously, if it is a S is a 4, and R is a 2, and Q is a 1, so that here your P is 3, right? Now, P3, Q1, R2, S4. So, your answer is here like this, okay? So, for solving this question, you need to answer, you need to know that, defects of the blank holding force, sorry, defects in the deep drawing cup, and then their possible reasons, okay? Right. Now, let us move for next question. Right, 17th question, MCQ, and it is a 1 mark question only. Hope you understand, guys. Hope you understand. Right. Now, which of the following pure metal has a hexagonal closed pack HCP structure? But here you need to know that crystal structure at room temperature. Please do remember, at room temperature. At room temperature. Right. Now here, so obviously aluminum is a FCC, copper is also FCC. Now iron processes different crystal structures at different temperatures. At room temperature it is a BCC, but here magnesium having the HCP. Right. Now your answer is A. Your answer is A. Now your answer is A. Crystal structures you're supposed to be learn. Right. For answer A. Answer A. Clear everybody? Right. Now hope you understand, guys. Hope you understand. Right. Now let us move for. Now we had been discussed this, guys. Aluminium, iron, copper. We had been discussed. Okay, have a look on this. Iron having the different structure up to 727 degrees centigrade. It is BCC. After 727 to 1400 degrees centigrade, it is FCC. Right. But they particularly asked at the room temperature. That is why at room temperature, it is BCC. All right. So that's the reason why magnesium having the hexagonal closed pack crystal structure. Right. Now let us move for the next question. Now to create 12 divisions on the disk by using the simple indexing and dividing head on a horizontal milling machine. Choose the correct option for the rotation of the crank pin. Choose the correct option of the crank pin. Here you need to know that indexing methods. We have a simple indexing, direct indexing, simple indexing, compound indexing, differential indexing. Most of the time the question is coming from direct indexing and simple indexing only, because these are angular indexing also there. 5 indexing methods are there. We focused on that angular 3 indexing methods. First one is the direct indexing, second one is a simple indexing, and third one is the angular indexing. Differential indexing and compound indexing takes more time. That is why most of the times questions are not coming from these two methods. Okay, if you want, I can write in a simple way. Right. Now here, indexing method, direct indexing, next is simple indexing, right? Third one is the angular indexing. Now fourth one is the compound indexing, and fifth one is the differential indexing. All right. Now here, so most of the times the question, not most of the time, very particularly, so we don't need to go for these two methods, right? And most of the time questions are coming from here only, right? Now here, if you see that it is the mention particularly simple indexing, right? Now what is indexing? Indexing is nothing but dividing the workpiece circumference into number of equal parts. Suppose if you want to produce a gear on a cylindrical job, then how many number of teeth you need to produce? How many number of teeth you need to produce? Right now, third division we will do with the indexing method. Indexing is nothing but, see, suppose this is circumference, right? Now dividing these circumference into number of equal parts called indexing. Okay, so through the indexing method, we divide the circumference of the workpiece into equal number of parts. Right now, here create 12 divisions on the disc and dividing head and a milling machine. So, having corresponding option rotation of the crank. Right now, here let us go for simple indexing. For simple indexing, simple indexing, crank rotation can be calculated. Crank rotation can be calculated. You know, so it is going to be a 40 by n. So now where n is equal to number of divisions required. Number of divisions required. All right, guys. Right. Now here number of divisions required in the problem is given 12. Right. 12 divisions. We need to divide the workpiece circumference of the workpiece. All right. Right. Now let us say that here crank rotation, we call it as a CR. Right. Crank rotation generally we call it as a CR. CR can be calculated by 40 by n. Right. Now we need to divide 12 divisions. Right. 40 by 12. Right. 40 by 12. Right. Now how can we write this? I can write it as 3 into, it is gonna be a 4 by 12. Right. Now in a 12 hole circle, for getting one divisions, you need to rotate 3 full rotations in the 12 hole circle. 4 circle has to be moved. Right now, this is a crank plate. In the crank plate, we have a different numbers of circles. Right, say it is a 15 hole circle. 15 hole circle. All right. Now, if it is a 15 hole circle, how can we do that? So now, if I wanted to get one division on the workpiece, I need to rotate my crank. I need to rotate my crank 3 complete revolutions in a 12 hole circle, and 4 holes after rotating 3 rotations, and then you just rotate 1, 2, 3 holes, and we have to, 4 holes we have to lock, so that you will get one division. So here you lock your crank pin. So after completion of one division, next division if you want, then again rotate the 3 rotations, and then from here 1, 2, 3, 4 holes has to be moved. 4 holes has to be moved. Then you will get another division. But here options are given. What is the options are given? So 15 hole circle, 16 hole circle, 18 hole circle, and 20 hole circle. You have to check. Right now here, you should make sure that your denominator must be 15 or 16 or 18 or 20. Right now, first let us multiply and divide with the 5. Then what you're going to get, 3 into, it is 20 divided by 60. Right here I require 4, 15. So that is the reason why here 4 3 into 5 by 15. Can I write like this? That means divide with a 4. So 4 fives, 4 15s. So 5 by 15. Right now here in a 15 hole circle, 3 full rotations and 5 holes has to be moved. 5 holes has to be moved. Right now in a 15 hole circle, 3 full rotations, 5 holes has to be moved. So that your answer is A. Your answer is A. Right But however, we will check this also. We will check this also. Any possibility of answer is this. Okay. Right. Now I have to make sure that it must be a denominator must be. So for B option we will select. So this is for A option. Right. For B option we will see. Now here this term will indicate that number of revolutions, number of complete revolutions, right? Now this indicates that 15 whole circle, 15 whole circle, right? So how many holes has to be moved? Holes has to move. Clear everyone? Right. Now here, so now let us see that B option also we will check. B option. So what is B option? B option 16 whole circle we have to make, right? Now here again crank rotation. So crank rotation is equal to crank rotation is equal to, it is going to be a 40 by 10, such that 40 divided by, again it is going to be a 12. Now here it is going to be a 3 into 3 into, it is going to be a again 4 divided by 12. Now we should make sure that 16 has to come down. 16 has to come down, right? Now I just multiply with a 4 by 4, such that it is going to be a 3 into, it is going to be 16 by 48. 16 by 48, right? Now here I just divide with a 4. So 3 into divided by 3, right? Now if I divide with a 3, then I'm going to get 16 here. Then if I divide with a 3, so 5 point, so 1 is there, right? 5.1 means 13. Now it is going to be a 3 will come, 5.3, right? Now here 16 whole circle, in 16 whole circle, okay, 3 full rotations and 3 full rotations and 5.3 holes. 5.3 holes are not there. Okay, right? Either 5 holes. It must be an integer. It must be an integer. It must be integer. Right? Now that is why this option is, B option is not correct. B option is not correct. All right. Similarly, you see that C option. C option is also not correct if you check that. Right? Now this also not possible. So all these are will come, not integers. It will come fractions. It will come fractions. That is the reason why here you select this one like this. Okay. Now make sure that 15 whole circle. 15 whole circle. I said that here 15 indicates that whole circle. This indicates that number of revolutions, and this indicates that holes has to be moved. Holes has to be moved. Clear, everybody? I hope you understand. I hope you understand. Like that, you are supposed to solve. Clear? Yes, guys. Yes, guys. Right. Now let us move for another question. Right. Now let us go for another question. Right. It is another tricky question, but however, it is easy to solve. Right. Now let me solve this. Now here, read the question carefully. The following layout for departments P, Q, or S is provided input to the craft. So what is craft? Computerized relative allocation of facilities technique. Okay. So you need to understand this, right? Now, which one of the following department pair cannot consider for exchange of craft? Exchange of craft. That means computerized allocation facility technique. computerized allocation of technique. Right now, so for this, we have to know one thing, that is share a common edge or be adjacent in the layout. Be adjacent in the layout. Be adjacent in the layout. Generally, this is craft is used for allocation of facilities. Okay, so what facilities we are having, according to that we are allocating the what is that work allocation, right? Now here, so let us see that first one. Right. First, we'll check that P and Q option. P and Q option. So here, P's dimensions are given, Q dimensions are given, R dimensions are given, and S dimensions are given. Right. Now, first we'll highlight that. Guys, got stuck. God. Guys. Yes, guys. Sorry, system got stuck. Right. Now let us move for. Now, see here. Now, computerized allocation, P and Q are four departments are given, P, Q, R, S are given, right? Now, craft technique, computerized relative allocation of facility technique. During manufacturing, allocation of resources, this technique will be used, right? Now, let us see that here, P department dimensions, Q department dimensions, R and S department dimensions are given properly. Let's check that options, P and Q. So, what they ask that, which one of the following department pairs cannot be considered for exchange? So, which pair of the department, either PQ has to exchange or R and S has to exchange, and PR can be exchanged, and Q and R has to be exchanged. This is what you are supposed to see. Clear, everybody, guys? Hope you understand. Let us check that. Let us check that. Right here, for understanding this, and share a common edge. When swap can be possible, for swap possible in the departments, must either, yes, for a swap to be possible, right? I'll write it as clearly. Have a look on this. For swapping the department, for swapping the department to be possible, the department must be, the department must be either share a common edge or either, first one, share common edge, or you know be adjacent in the layout, be adjacent in layout. Hope you understand, guys. Hope you understand. Right now, let us see that what pair is going to be share common edge, and first option, and which adjacent is the layout, right? Now let us see that first one, option A, option A, right? Option A. PQ vertical edge is sharing, right? P and Q, vertical edge is going to be share. Vertical edge is going to be share, right? P and Q. P and Q, vertical edge is sharing, right? So vertical edge sharing. So any common edge is going to be shared, so that swapping is possible. So swapping possible. So solving these kind of questions, guys, you just remember these 2 points. Either common edge has to shade or adjacent is in layout. Adjacent in layout, right? Right. Now let's see that R and C options, right? R and S option, right? So here swap is possible. R and S. R and S is also vertical edges sharing. R and S is also vertical edges sharing, right? Now option B, R and S also share vertical edge. Vertical edge. Such that what happen? So swapping is possible. Above one condition is satisfied. Swapping is possible. Clear, everybody? Right. Now let us see that. C. What is the option? P and R. P and R. See the P and R. Horizontal edges sharing. P and R. P and R. Horizontal edge is going to be share. Horizontal edge is going to be share. Right. Now here for C option is that P and R. P and R. Horizontal edge is sharing. Horizontal edge is sharing. All right. What happened? So swapping is possible. So swapping possible. Yes, guys. Swapping is possible. Right. Next, D option. What is the D option? Q and R. So Q and R. Q and R. No, do not sharing any edge and do not adjacent layout. Okay, these are not Q and R. Q and R not sharing any edge, and also they are not adjacent layout. Right. Q and R. Q and R not sharing any edge. Not sharing any edge and not adjacent layout. Not adjacent layout. Then swapping is not possible. Swapping not possible. All right, guys. So here, what is that? They ask that which department is not, which one of the following department pairs cannot consider for exchange of craft. So Q and R are not sharing any common edge, and they are not adjacent layout. That is why these two fellows are not going to be, swap. So your answer is D. Your answer is D. So right now here, guys, so if you remember these 2 points, so that it is easy to solve this kind of question. Hope you understand, guys. Hope you understand. Now let us move for next question. Let us move for next question. Right. Now next question is that which of the following concept is not closely interrelated with the interchangeability to construct of product design? Interchangeability. What is interchangeability? Actually, we are producing the components, lot size, 2 mating parts. So one mating part and another mating part we will produce. Suppose say that here we will produce bolts. Large number of bolts we produce in the section 1. Now here we are producing the nuts here. Now, so in you select any bolt, and according to you will select nut which is going to be fit in the bolt, right? So here here 100 nuts are there, here 100 bolts are there. So you take one one nut, sorry, one bolt, you will select the one nut, any one nut which is going to be fit in the bolt. Like that, interchangeability is going to be designed, right? Now here, which term is not going to be related to this? Standardization, obviously. So bolts and nuts must be standardizedly be manufactured. So it is related to the interchangeability. Now, which is not closely interrelated, guys, which is not interclosely related? Specification, simplification, obviously it is going to be simplification must be there in the interchangeability, right? Diversification, specialization, right? Now here, uh, diversification is not related to the interchangeability. That is why here your answer is C. One more question, guys, one more question, right? Now let us move for next. 29, question number 29 for 1 mark. So, which of the among following is a true for friction stir welding? What are the statements are true for the friction stir welding process? For that, we need to understand what is friction stir welding, right? Now, in friction stir welding, here lap tap joints and butt joints are going to be produced, right? This is a one plate and this is another plate, right? Now, this is with the center. In the center, there is a tool, friction stir tool is there. It is called shoulder pin. So this pin is inserted and it is continuously rotated. Some vertical force is going to be acted here and it is moving in this direction. So that here rotation and force and linear movement of the tool are the parameters of this particular friction stir welding process, right? Now, first, the pin is going to be inserted into the two plates to be joined, and then it is continuously rotated such that the material will get disturbed under the pin because of the force acting, so that the material itself plastically deform here and joint is going to be produced. It is a solid state welding process. I have told you solid state welding process. Solid state welding process. Clear, everybody? Hope you understand, right? Now, what are the statement? It can be used to produce lap butt joints and T joints. Obviously, it is going to be correct, right? Now, a non-consumable rotating tool with shoulder and pin is used to melt the workpiece material. However, see, shoulder, pin, and non-consumable rotating tool, right? Now here it is a non-consumable rotating tool and it is having shoulder, it is having fin. That is correct. But these are not going to be melt the workpiece material. So in friction stir welding process, material is not going to be melt. So this statement is wrong. It is a solid state welding process. Next, retracting side of the weld where linear velocity vector at a point on the side of the rotating tool and the welding direction are opposite. No, right? Now here, so linear velocity vector and welding direction both are same, right? So now welding direction means in this direction weld is going to be formed, and the same direction velocity of the tool is going to be move, right? Now they are telling that it is a rotational in a welding direction or opposite, right? Now this statement is also wrong, right? Now advancing weld where linear velocity vector at a point on the side rotating tool or in the opposite direction, this is also wrong. So your answer is yeah. Your answer is yeah. Hope you understand, guys. Hope you understand, right? Now let us move for another question. Right. Now here, a blank diameter 100 mm is to be cut from a 2 mm thickness of sheet through the blanking operation. So here clearly mentioning that it is a blanking operation. It is clearly mentioned that it is a blanking operation. Right. Now, if the radial clearance between the punch and a die is 6% of the sheet thickness, then diameter of the punch will be okay, clear, right? Now here let's see that blank diameter D is equal to, it is going to be a 100 mm, right? Thickness of the sheet, they are telling that what is the thickness of the sheet? Thickness of the radial clearance of the punch, thickness of the sheet is 2 mm. Now clearance is equal to what they mentioned, 6% of sheet thickness, right? Now clearance is equal to 6% of thickness, such that I can write it is 6 by 100 into 2. What do you say, guys? 6 by 100 into 2. Right. Now it is going to be a going to be a, so 12 divided by 100, such that I can go, it is 0.12 mm is a clearance. Right. Now, I told you one table to you guys. Do you remember in blanking operation? In blanking operation. So, in blanking, I'll write it as again. In blanking, blank size equal to die size, and clearance provided on the punch, right? So now clearance provided on punch. All right. Now here punch size is equal to what we need to find, punch size only, right? Now punch size is equal to die size minus 2c or blank size minus 2c. Both are same. Blank size equal to die size na? Minus 2c, right? Now let us move for blank size. Punch size is equal to this. We have solved so many questions, guys. So blank size 100 minus 2 into 0.12, right? Such that it is going to be a 100 minus, so 0.24. So now here I can write it is 99.76 mm. This is what your punch size. Okay, right. Now hope you understand, guys. So in blanking and punching, I told you in punching what happened, punch size equal to whole size. Now die size equal to punch size plus 2c. Now here it is a minus 2c. That's it. Only very simple. So how simple it is? One more question. Yeah, great. Now let us move for another question. Right. Now in the iron carbon equilibrium diagram, it is another. So what's your answer here is? Answer I'll write at the top. Answer is equal to, it is going to be a 99.76. Now let's see that another question. It is another 2 marks question, guys. We have solved in the class. Have a look on this. In iron carbon equilibrium phase diagram, the temperature and composition of the eutectoid point at the eutectoid point are 727 and 0.77% carbon respectively. If the steel specimen 1.2 weight of carbon percentage is cooled from the 1000 degrees centigrade to the room temperature, then the fraction of the pro-eutectide cementite phase in the steel. Okay, right. Pro-eutectide cementite, we need to find that. Pro-eutectide cementite, we need to find. Now let us solve the question. Right. For this, I need to draw the diagram, guys. Okay, for that I'll go for the next, so that it is possible for us to understand very easily. Right. This is a percentage of carbon, and here it is a temperature. All right. Now here what they are telling, at 727 degrees centigrade, 0.77 percentage is a eutectoid point, right? As per so our discussion, as per our discussion, only one part I'm going to draw. Now here, so at 727 degrees centigrade, at this point, the carbon percentage is 0.77. All right. Now this, they are telling that your eutectoid point, right? Now what they're telling, this is what the data given. So 777 at 0.77. Actually, our discussion is, we have discussed it is a 0.8, but according to the problem data, you need to solve. Don't take it as a 0.8. So if you take 0.8 from this problem, you will get the wrong answer. But according to the data, you solve, right? 727 at 0.77 eutectoid point. So at eutectoid point, perlite is 100%, isn't it? Perlite is 100%. Yes, guys. Right. Now let us move on. Next, what they gave that respectively. If steel specimen 1.2% weight of carbon is cooled from 1000 degrees centigrade, then room temperature, what is the fraction of pro-eutectoid cementite? Right. Now here, what they're telling that, guys, what they're telling. Now here, 1.2% carbon steel is going to be cooled from 1000 degrees centigrade, say somewhere here 1000 degree centigrade, right? Now from here 1.2% carbon steel is going to be cooled from this one. Now obviously, as our discussion, right, as of our discussion, we understand that, to first Fe3C. That means cementite will form this side. This side ferrite will form. So, and this is a austenite, 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 and austenite, right? Whatever the cementite is formed in this region, we call it as a protectoid cementite, right? So here at 0.77, 100% perlite, right? Now here at 6.67, so Fe3C, 100%. Right now what we need to calculate, Fe3C, protectoid Fe3C, right? Now apply lever rule. By lever rule, right? Tie line, take the tie line. This is a 0.77 and 1.2 and 6.67, right? Now as per our discussion, I told you that at 0.77, 100% perlite, right? At this stage, 100% Fe3C, right? Now here we require protectoid cementite. We require protectoid cementite, right? Now protectoid cementite Fe3C is equal to. So if I require this side, that is why this tri line divided by total tie length. So here 1.2 minus 0.77 is divided by 6.67 minus 0.77 total length. Then if you solve this, then we are going to get this 0.43 and is divided by 5.9. So you are going to get it is a 0.072 we'll get, right? So now let's check the answer. 0.07 is a correct answer. Your answer is A. It is another 2 marks question, right? Now this question we have solved in the classroom. Have a look on that. Have a look on that, guys. Okay. Right. Now let us go for another. Okay. Now let us move for another question. Let us move for another question. Right. Now have a look on this question, guys. Now, right. For polymer, match each process with a suitable application listed. Suitable application listed. Right. Now, extrusion, injection molding, blow molding, and compression molding, right? Now first one is the extrusion. We will see. So extrusion we have discussed. So what is that? Producing complex parts, closely tolerances? No. Producing the thermosetting plastics? No. Producing long uniform sections, right? Now here P is equal to, it is going to be a 3, right? Next, blow molding is used for producing hollow shapes. Blow molding is Q, R, and S, right? Blow molding used for producing bottles, water bottles, hollow shapes, right? Now here, so R is equal to 4. Now here P3 R4. So P3 R4, this is not answer. P3, so P3 is there. No, this is not P3 and this is not P3. So now P3 R4, so that you can eliminate answer like this. If you know any two, so that it is possible to find out the rest. Now see that injection molding, producing complex shapes. Obviously injection molding used for producing the complex shapes, Q1. Now so S is compression molding, so producing the thermosetting plastics. Okay, now this is going to be a 2, right? Now this will be the answer like that. Now you know extrusion and if you know blow molding, so that it is possible to eliminate the answer where P3 and R4 is there, then you can select that. Right now, here answer is D. All right, guys, like that. Next, one more question. So, in forming operation, plastic deformation of a steel specimen, it is a forming question, guys. It is a forming question. Right. Now, in forming operation, plastic deformation of the steel specimen stored under the plane stress condition, where principal stresses are sigma 1 200 megapascal and sigma 2 100 megapascal. If the steel specimen follows one masses yield criteria, right? Then the uniaxial tensile strength is okay. Now here I would like to give you one statement here, guys. One statement I would like to give here, right? According to the one masses yield criterion, right? The yield stress is tensile yield strength. Tensile yield strength is correct. Now here I would like to highlight one thing, that is yield tensile criterion. Yield tensile criterion is equal to, it is going to be a half into, it is going to be a sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square under root. Right? Clear, everybody? Right. Now here sigma 1 is equal to, now here sigma 1 is equal to 200 megapascal. Right. Now sigma 2 is equal to 100 megapascal. Now sigma 3 is equal to 0. Clear? Right. Now here sigma, why? Because it is not given. Right. Now here sigma yield stress is equal to, it is going to be a half into, so sigma 1 minus sigma 2. So here 200 minus 100 whole square plus, now sigma 2 minus sigma 3. Sigma 2 is 100 minus 0 whole square plus sigma 3 minus sigma 1. 0 minus 200 whole square under root. Now here half, it is going to be a 100 square plus 100 square minus 100 square plus 100 square, right? Minus 200 square, 200 square under root. Now here half, so 100 square is 10,000 plus 10,000 plus, it is going to be a 40,000. All right, this is under root. From here I can write it as 60,000 is divided by 2 under root, such that 30,000 root, so that it is going to be a 173.20 megapascal. All right, now here your answer is A. Your answer is A. Like that. So for solving this question, you need to know the one masses yield criterion. Okay, so hope you understand, guys. Now let us go for another question. Now have a look on this question, guys. Have a look on this question. Another MCQ. Right. Degree of freedom. Right. Now here jigs and fixtures have to study. Right. Now here configuration. Match the following listed 3 degree of freedom industrial robot with a type of joint, right? Now here, uh, Cartesian is a one Cartesian, cylindrical, spherical, and art- articulated configuration is given, and type of joints given. So which configuration is going to be produced, which type of joints? So prismatic and two rotatory, three rotatory joints, and two prismatic and one rotatory, and three prismatic, right? Now here what we need to understand, so Cartesian. So Cartesian is going to be produced three prismatic joints. Okay, three prismatic joints. So here, so P, Q, R, and S. Right. Now here I understand that Cartesian is going to be produced three prismatic joint. Right. Now P4. Now cylindrical, obviously cylindrical is going to be produced with a two prismatic and one rotatory. Two prismatic and one rotatory. So cylindrical two prismatic and two cylindrical. So Q3. Right. Now spherical. So spherical is going to be produced one prismatic, two rotatory. Right. One prismatic and two rotatory. So R is 1. Now here it is going to be a P4. Now Q is going to be 3, right? So R is going to be 1, right? Now here P4, Q3, R1. So S is actuated obviously a 3 rotatory joint. Now it is going to be a 2. So your answer is B. Your answer is B. Right. Now it is essential to study that configuration and which type of motions they are going to be produced. Right. Based on that, you can decide the joints. Okay. Hope you understand, guys. Hope you understand. Now let us move on. Next question. Right. Now choose the. It is another question. Choose items which are required to make an eccentric hole on a disc, as shown in the figure. Eccentric hole on a disc. If you have a disc, and to the disc on the disc you need to produce a eccentric hole. Eccentric hole. Right. Now here in lathe also we can produce. In drilling machine also we can produce this eccentric hole. Right. Now single point cutting tool, not possible. So with the only single point cutting tool it is not possible to produce the eccentric hole, right? This option is not correct. Now forger check, in lathe with the help of forger check we can produce the eccentric hole. That is the reason why here this is the correct option. Drill bit, with the help of drill bit also we can produce the eccentric hole. Three jaw check, so three jaw check is a uniform check, that is why it is not possible to produce the eccentric hole, right? Now here answers are either B or C. You can keep any one so that you can get the answer, or B or C. So strictly speaking, it is a forger check only. Eccentric hole can be produced with a B and C. But here, eccentric turning forger check. But they said that eccentric hole. That is why with the help of drill bit also we can produce the eccentric hole. That is why C option is also correct. Hope you understand, guys. Hope you understand. Please do respond. Good. Very good. Very good. Right. Now let us move for another question. Right. Now 52, question number 52 and MCQ. Right. Now mild steel plates are welded to make a butt joints by arc welding with heat transfer efficiency 85%. Right. Now eta T is given. Right. Eta T is given. Mild steel plates welded to make butt joints by arc welding with heat transfer efficiency this much. Ignoring other losses. The first weld joint, two weld joints are there, guys. In the first weld joint made by using selecting a voltage is given, current is given, and welding speed is given using identical plates. And second joint made with the same arc voltage. Arc voltage is same, and the welding speed is different. If both welds having same heat input, then welding current will be, for the second case we need to find out the welding current, right? So first we try to write the given data. Try to write the given data, guys. Right now here heat transfer efficiency is equal to, it is going to be a 75%, right? Now first case we'll highlight first case. First case, what is in the first weld joint made, selecting the arc voltage. In the first case, voltage is given 30 volts, right? In the second, first case, welding current is equal to 180 amperes, right? With a welding speed is equal to, it is going to be a 6 mm per second, right? Now, this is what made in the second case. second case. In the second case, what they said that in the second weld joint made with the same arc voltage, right? Now here second case is also voltage is 30 volts and welding speed is also given, that is going to be a 8 per second, right? Now if heat input in both cases heat input will be same, then welding current we need to find. Welding current we need to find. Welding current we need to find. Clear, everybody? Right. Now, in both cases, heat input is same. Right. Now, here, what is heat input? So, if we gave V, I, V, and heat transfer efficiency, then how to calculate the heat input? I gave you the 3 formulas, guys. Have a look on that. Go to our lecture notes so that you will be able to find that. Heat input in arc welding. Heat input is equal to, it is going to be a V into I into heat transfer efficiency is divided by, welding speed, such that your heat input you will get joule per mm. Heat input you will get joule per mm. So what? So here watts by mm per second. What means joule per second, right? Second will get cancelled. Then joule per mm is going to be get. Did you remember, guys, units? So here it is going to be a watts and divided by mm per second. What I can write it is joule per second and is divided by mm per second, right? Second will get cancelled, then you will get joule per mm, right? Now here first case, for the first case, right? Heat input for the first weld joint. Heat input for first weld joint. Now here heat input is equal to, it is going to be a first case, V is 30, 180 and 6, right? So now voltage is 30, current is 180 into heat transfer efficiency 0.75 and is divided by 6, such that you are going to get, if you solve this, then you are going to get it is a 765 watts are going to be get. But in the problem they said that in the second case, this is the data, both weld have same heat input, right? That means whatever the heat input is there, that is for similar for second case also. For second weld joint, heat input for second weld joint same as first joint, right? That means here heat input for second case. What is the heat input for second case? Heat input for second case, again V into I into heat transfer efficiency divided by welding speed, right? Now here what is welding voltage? 30 volts, speed is 80. 30 into I, we don't know, into heat transfer efficiency 75 and is divided by 8. But heat input is same now. That is why I just equate this equation with a 765, right? Now here 765 is equal to, it is gonna be a, what is that? V 30 volts, 30 only now. Yeah, 30 volts into I into heat transfer efficiency 0.75 and is divided by 8. Now from here I can get 765 into 8 and is divided by 30 into 0.75, so that I'm going to get my I is equal to 240 amperes. 240 amperes. Right. Now here if I multiply with this, I'll get 6120 and is divided by 75, 0.75 and 30, such that I'm going to get is a 25.5. So if I solve this, then I'm going to get it as a I is 240 amperes. Now here your answer is 240 amperes, right, guys? Now I told you that here three formulas I gave. We just go back to our welding note. So in arc welding, I gave that heat input formula. So first case, you calculate the heat input, and then this heat input equate to the second case, so that you will get the I. That's it. Very simple. Right? 2 marks in your pocket. I told you in the beginning itself. Right? Now let us move for another question. Right? So in a single pass cold rolling operation, rise. Okay, a flat plate is reduced to thickness of 3 mm. So HF is given. Final height of the component is HF is 3 mm. In this operation, two rollers of diameter of the roller is also given. That is D is 400 mm. Each rotating in opposite direction at a speed. Rolling speed is also given. Rolling speed is also given. Yes, guys. Now here, what I'm trying to tell you. Okay. Now these rollers. Okay. Right. Now here, the rolls deflection of rolls is negligible. The angle of bite is given. Alpha is given. Right. Neutral plane present at a angle of 7 degrees. Sustaining angle theta is also is given. So neutral plane, neutral point is presented at an angle 7 degrees from the exit side. Then thickness of the plate at neutral point. So what we need to find, guys? HN you need to find. Right. First write the given data. So we have solved this problem in the class itself. However, we will write again. Okay. HF is equal to, it is going to be a 3 mm. Right. Diameter of the roller is equal to, it is going to be a 400 mm, such that I can write my radius is equal to 200 mm. All right. Now here RPM of the roller is equal to 300 RPM. Now here alpha bite angle is equal to, oh my god, not 10 degrees it is. Now theta is equal to, it is going to be a 7 degree. All right, from the exit side. Now what we need to find? HN we need to find. Clear everybody, guys? Clear everybody? Hope you understand. Clear? Right. So for that, with the help of diagram, we will use to solve this question. With the help of diagram, we just used to solve this question. Have a look on this. Have a look on this, guys. Right. Let us move. I have a diagram here. Right. I know that, guys. I know that. Now alpha is 10 degrees, right? Alpha bite angle is 10 degrees, right? And I know that now what we will do, and sustaining angle. So that sustaining angle also we'll try to draw this. Right? Now from the exit, the sustaining angle will be 7 degrees. And here, from here the neutral plane is going to be presented. This is what the neutral plane, right? Now, and this is given. So HF is equal to 3 mm is given. 3 mm is given, right? Now let's move for, guys, as we understand that, listen carefully. However, we have solved in the class, but listen carefully. This distance is that delta H by 2. That is equal to H naught minus HF by 2. Clear, everybody? Right. Now here, so let us join these two fellows. Now take this point A, take this point B, right? Our intention is that we need to find this thickness. This is HN. We need to find. Thickness at the neutral point, we need to find. This we have already discussed. This is alpha equal to 10 degrees and theta equal to 7 degrees. Isn't it? Sustaining angle theta. Angle of bite is entry point. This is an entry. And here, this is going to be a exit. Right? Now here, let us see that. Now here, this is a HF. H naught, this is. We don't know H naught. Okay. This distance is a H naught. This distance is a HF. Now from here, we need to find this one. Right. Now from triangle OAB, this is a perpendicular triangle OAB. So what is this distance, guys? How can we write this distance? This distance, I can write it is, this distance, I can write it is R cos theta, right? This distance is equal to, it is going to be a R cos theta from triangle OAB. So OB is equal to R cos theta from triangle OAB. So cos theta is equal to, it is going to be a OB by OA, right? So OB we require, right? OB is equal to, it is going to be a OA into cos theta. So what is OA? OA is the radius, right? This is the radius, right? Now here I can write it as a or cos theta, right? Similarly, from the triangle OAB, sin theta is equal to, it is going to be a AB by OA, AB by OA. Now here I require AB such that AB is equal to OA into sin theta, such that OA equal to again R sin theta. So here this distance will be the R sin theta, or sin theta. Isn't it clear, everybody? Clear, everybody? Please do respond. We have solved this question, guys. We have solved this question. I gave you one technique as well. All right. Now this is OAB, and this point I'll take C. This point I'll take C. This point I'll take C. Right. So I require BC. I require BC. Right. Now can I write this? Can I write this as BC is equal to, BC is equal to OC minus OB? Can I write OC minus OB? Can I write? Yes. See, BC is equal to this point. BC is equal to, I can write OC minus OB so that I can get BC. Now, what is BC? This is important. This is important, right? What is BC? This distance. This distance. If this distance delta H by 2, that is H naught minus HF by 2. So from here, from H naught it is started. That is why H naught minus HF. And here it is ended here, right? Now from here, it is started from here. So what is the distance Hn? Can I write this fellow Hn minus HF by 2? Yes, obviously. So here I can write it is this distance. This distance is H naught by 2. That is H naught minus HF by 2. So from the same logic, I can write it is Hn minus HF by 2. Hn minus HF by 2. This distance, guys, same. This is both for both ends, it is same. This distance is equal to Hn minus HF by 2. Both side same, right? Now this distance BC equal to, now here I can write it is equal to, BC is equal to, it is going to be a Hn minus HF by 2, right? Now let's say you write here how simple and easy it is. Now BC is equal to, it is going to be a Hn minus HF is divided by 2 is equal to, what is OC? OC again R minus OB. OB is equal to R cos theta. Or cos theta. Isn't it, guys? Right now here R into 1 minus cos theta. Now here it is going to be a Hn minus HF by 2. Right? Now here let us simplify this. I require Hn. I require Hn. Right? I can write my Hn minus HF is equal to, it is going to be a 2R into 1 minus cos theta. Clear? Right. Now I require Hn. Right. Now I can write my Hn is equal to, it is going to be a HF plus 2R into 1 minus cos theta. All right. Now here HF 3 mm plus 2R. 2 into R. R is given in the problem, na? 200. R is 200. Right. Now here 2 into 200. Directly you can write 400 also, no problem. 1 minus theta is equal to, now here theta is equal to, here theta is equal to 7 degrees. So we have written here 7 degrees, right? Now let us write that here 7 degrees is equal to, it is going to be a 3 plus 400 into 1 minus, let us see that then if you solve this, then cos 7 degrees you find, and then if you solve all those, then you're going to get your HN, neutral plane thickness, 5.98 mm. Okay, 5.98 mm. Clear everybody, guys? Clear everybody? Hope you understand. Hope you understand, right? Only thing is here you need to understand. So what is a BC distance? BC distance is the HN minus HF by 2. This side HN minus HF by 2 reduce. This side HN minus HF by 2 is reduced. So from here you just form the equation. BC equal to, it is going to be a OC minus OB, so that you are going to get this much. Hope you understand, guys. Hope you understand. Clear everybody? Right? Right. Now your answer is here. So 5.98 mm. So you can get the answer 5.8 to 6.1. No problem. So 5.8 to 6.1 is acceptable. Okay, right. Now let us go for another question. Right. Now in a sand casting process, in a sand casting molding, sprue height is H2 is given 200 mm. H2 is equal to given 200 mm. Right, is to be provided. Maintaining a molten metal flow rate is 10 power 6 mm cube per second. The height of the liquid column above the point 2 kept constant, H is equal to 25 mm as well. Okay, right. Now here total height, right, sprue height plus HT is equal to sprue height H2 plus HC, such that I can write it is going to be a 200 plus 25, such that it is going to be a 225. Clear everybody? Hope you understand. Hope you understand. Right, now the cross sectional area at the sprue point 2. Right, now here the cross sectional area at point 2, say it is going to be a A2, right, and cross sectional area at point 3 is going to be A3. So now here the cross sectional area at point 3 we consider it as a A3. Right, now the point 1 and 3 are open to atmospheric pressure, assuming that gauge pressure at point 2 to be 0, as eliminating the case of preventing aspiration effect. Then ratio of A3 by A2. Then ratio of A3 by A2. What we need to find, guys? A3 divided by A2 ratio we need to find if you want to avoid the aspiration effect. Right, now here, guys, in the first casting class, we have discussed and we have solved this problem as well. Okay, right. Now here let us move for. What is a condition I gave you to solve? What is a condition I gave you to solve this particular aspiration effect? Right, now here, did you remember condition? So to prevent aspiration effect, right, what is the condition, guys? So I told you that it is a A3 by A2 is equal to, it is gonna be a, right, HC divided by HT under root. Yes, right. Now HC is given, HT also given. HC how much? HC 25 and 225. Right, now here, so HC 25 and total height is 225 under root. Now here it is gonna be a, 0.33 will come. All right, now here we can write it as a 1 by 3. That is A3 divided by A2. Right, now here 0.33 answer. Now you can, your answer may be vary, so 0.312, 0.35, not a problem, but you will get exactly 0.33, I'm sure, if you solve this. Right, 0.33. Right, so 25 is divided by 225. Right, now if you want to simplify this, 5 5 jars and 4, and is divided by 4 and 5 under root. So 1 divided by 9 under root. So such that it is going to be a 1 by 3. So 0.33. Right. So it's a 2 marks gate question, guys. How simple and easy. If you understand and to prevent aspiration effect condition. So if you remember this condition, then it would be very easy to solve this kind of question. Clear? I hope you understand, guys. I hope you understand. Right? Now let us move for the next question. Question number 55. Question number 55, guys. Question number 55. Right. Now the following data are given relation to the turning operation. So turning operation of a cylindrical workpiece. Turning operation for a cylindrical workpiece. Diameter of the workpiece is given. Length of the workpiece is given. Cutting velocity is given. Now, and tool feed is also given. Assuming that approach and overrun are 5 mm each side. Then machining time calculation, right? Machining time calculation. It is a turning operation. First, let's write the given data first, guys. First, write the given data. So diameter of the workpiece. Diameter of the workpiece is equal to 160 mm. Now, length of the workpiece is equal to 190 mm. So many examples we have solved on this question, guys, right? Cutting velocity is equal to 80 pi meter per minute. All right. Right. Next, what is given? Feed rate. F is also given 0.2 mm per revolution. Right. Now, what is the machining time? Approach and overrun. Both are approach equal to overrun equal to. It is going to be a 5 mm. All right. Now, what we need to find? Machining time calculation. Right. Now, here machining time, we have a formula that machining time is equal to L divided by F dot N. L divided by F dot N. Clear, everybody, guys? Hope you understand. Hope you understand. Yes, I'm in class. Call you later. Okay, guys. Right. Now, let us move for next question. Sorry, not next question. Let us see. What is L? L equal to length of the tool travel. That is approach plus length of the job plus overrun. Approach plus length of the job plus overrun, guys. Right. Right. First, write the given data. Write the given data. So later we will go to solve the question. I'm in class. Call you later. Hello. In class. Yeah. Call you later. All right. Now let us see. Now here I'll just give you the small diagram in order to understand this. Right. Now here this will be your workpiece, and this is a length of the workpiece. Right. Now diameter of the workpiece is 160 mm. Length of the workpiece is 190 mm. All right. And approach. So suppose tool is here. Tool is here. Approach. And here overrun. Right. Now here this is all length of the tool travel, capital L. So now capital L is equal to, it is going to be a approach plus length of the job plus overrun. We had been discussed, right? This is a 5. This is a 190. Plus this is OR is also 5, because approach and overrun they mention 5 mm each, right? Now here it is going to be a, guys, 200 mm is the length of the job, right? Now, so machining time calculation, L is, we know, L divided by F dot N. So we don't know N, RPM we don't know. So cutting velocity is equal to, it is pi d N by 1000, right? Now V is given, cutting velocity, how much? 80 pi. Right. Now here it is going to be a 80 pi is equal to pi into D is 160 into N is divided by 1000, right? Now here if we solve this, N equal to, it is going to be a 80 into pi into 1000 and is divided by, why multiply 1000? Because it is given meters. I just converted into mm per minute, right? Now after that it is going to be a pi into 160, such that 82. So pi will get cancelled. So 80 times 2 times, so that it is going to be a 500 rpm will come, right? Now substitute all the values. So substitute all the values, right? Now machining time calculation is equal to length of the job 200 and into feed. Feed is 0.2 mm per revolution. 0.2 into N is RPM 500, right? N is equal to, here it is going to be a 500 RPM, right? Such that it is going to be a so 200 is divided by 0.2 into 500 is a 0.2 into 1000, and it is going to be 100. Right now it is going to be a 2 minutes. Machining time is equal to 2 minutes. Hope you understand, guys. Hope you understand. Right now your time will be, machining time is equal to 2 minutes. Right, we have solved so many questions in that. Have a look on that, go back to our example so that you will be able to understand easily. Now let us move for another question. Right, it's another tricky question. It is a level 3 question, but it is not quite tricky, guys. It is not much difficult, but the thing is, here you need to concentrate more on this question. Right now let us move for solving this question. In a CNC milling path, in a CNC milling operation carried out by moving a tool from the point A to point B. So CNC milling tool moving from point A to point B, right? Now point A and B is given. Point A 0, 0, point B is given. It is going to be a 10, 10 is given in the problem respectively. All dimensions are in mm. If feed rate from the point P along x-axis is given, feed rate along x-axis is equal to 6 mm per minute, right? Then feed rate in mm per minute point P. So along y-axis we need to find. Along x-axis is given. Along y-axis we need to find. Now let us solve this question. Let us solve this question right now. In a CNC milling path, the tool follows a quarter circle. Now let me write point to point so that you will be able to understand very well, right? In CNC milling path, in CNC milling path, right? Now tool moving a quarter circle path, from point A to point B. All right, point A to point B with C as a center. With C as a center. All right, guys, with C as a center. So from this center, the tool is moving from A to B. That point location is also given, right? So now here feed rate along x-axis is given. We consider feed rate along x-axis at point P. At point P. So here I can say it is Vx is equal to 6 mm per minute. We need to find Vy. This is what the given data of the problem. All right, guys. Now let us go for now circular motion. From circular motion. Okay. The relationship between the feed rates based on the parametric equation of the circle. The relationship between feed rates based on the parametric equation of the circle. Based on parametric equation of circle. Parametric equation of circle. All right. So what is that? For circle center, for circle center 0, 10, right? C, right guys? Here see that here it is a 0 comma 10, 0 comma 10. Yes, right. Now let us move for with radius r equal to 10. Now here x equal to or cos theta and y equal to or sin theta plus 10 guys, or sin theta plus 10 because of radius. All right, now differentiating with respect to t, differentiate with respect to all of this. Now here vx I can write it is vx is equal to minus or sin theta dt by d theta by dt, right? Now here differentiating with respect to t or cos theta minus sin theta differentiation, right? Similarly vy is equal to or sin theta is a cos theta derivation, and it is going to be a dt by d theta by dt, right? Now here 10 is a constant, that is going to be 0. Okay, hope you understand guys, hope you understand, right? Right. Now let us do that vy by vx, right? Now here vy by vx such that what is vy or cos theta d theta by dt and divided by minus or sin theta d theta by dt such that I can write or will get cancelled. So here I'm going to get it as a minus cos theta divided by sin theta such that I'm going to get minus cot theta guys, right? Minus cot theta, right? Right. Now let us move for the next step. Point P pathway along a quadratic circle at an angle theta. P can be determined from its coordinates from the figure. Right. Now here point P, here point P pathway along the quadratic circle, pathway along quarter circle, quarter, hey, stop, quarter circle, the angle theta, the angle theta at P can be determined by, can be determined by coordinates. Now here xp is equal to, it is going to be a 6, and yp is equal to, we don't know, right? Here xp is given, this is your xp. Now we don't know that yp, y coordinate at p we don't know, x coordinate we know, so this is x guys, this is a x, right? That is what from the coordinate using this equation, using circle equation I can write little cautious regarding this problem guys. Using circle equation, using circle equation, right? How can I write x square plus y minus 10 whole square is equal to r square, right? Substitute x equal to 6, r equal to 10, where x equal to 6 and y equal to we don't know, then r equal to 10, you substitute in this equation. Now let us move for solving this question. X is equal to 6 now, right? Now here 6 square plus y minus 10 whole square is equal to 10 square, such that it is going to be a 36 plus y minus 10 whole square is equal to 100, right? Now here y minus 10 whole square is equal to, it is going to be a 64, right? Now here y minus 10 is equal to, it is going to be a 8 plus or minus 8, isn't it? Y minus 10 equal to plus or minus 10. Now y equal to, it is going to be a 18. Clear everybody, guys? Clear everybody? Right. Now here this will be the plus or minus, but here y is above x coordinate, p is above x coordinate, that is why it is plus only, that is why it is plus only, right? Now here let us move for, now it is move for, let us move for the next question, guys. Let us move for the next question, right? I'll call you later. Right. Now here why we consider it is 18, why? Because it is a above x coordinate, above x coordinate, right? Now slope at p, oh my god, slides are over, guys, please be here. I'll copy some slides and come. Slope at p, at point p, slope tan theta, slope is tan theta, right? Now here tan theta is equal to, is going to be a y minus 10 is divided by y minus 10 is divided by x, right? Now here y minus 10, y equal to 18, so 18 minus 10 is divided by, you know, here y coordinate, guys, y minus 10, so here y coordinate is here, this will be the y minus 10, okay, this will be the y minus 10, this is a 6, that is what I wrote. So here if I wanted to slope tan theta na, so tan theta equal to y by xp, right? Now here that is what I wrote here, right? Now x equal to 6, such that it is going to be a 8 by 6, so that we are going to get it is a 4 by 3 is a slope, 4 by 3 is a slope, right? Now cot theta, right? Now I just write this is what the tan theta was. Now cot theta is equal to, it is going to be a 3 by 4, right? Now substituting cot theta, v's vx value, substitute, so cot theta 3 by 4 and x equal to 6, vx equal to 6 mm per minute, 6 mm per minute, right? Now what is our equation? vy minus vy is equal to minus vx into cot theta, that is what we have discussed now, right? Now let's write minus 6 into 3 by 4. Now here I can write this fellow, it is 18 by 4 minus, such that it is going to be a minus 4.5. So vy is equal to minus 4.5. But here it is a above upward direction, so that minus has to be neglected. Now vy is equal to 45 mm per minute. Clear everybody, guys? Now nothing is there. See here, I just substituted my in this equation, right? What is this equation? See guys, vy by vx equal to minus cot theta. since we know one thing, substituting that Vy by Vx is equal to minus cot theta. Na? So in this equation, I substituted Vx and cot theta value. Then I'll get the Vy. So Vy is equal to 4.5 mm per minute. Right now, your answer is here. It's a little lengthy question, but you should concentrate well. Then it is easy to solve. 4.5 mm per minute. Clear, everybody, guys? I hope you understand. I hope you understand. Right now, let us move for another question. Let us move for another question, guys. Let's see that another question. Right now, a pitch of the metric thread is calculated from the pitch circle diameter measured through two-wire method. If the thread is tried single start with calculated pitch is 1.4 mm, then the diameter in mm. Then the diameter in mm. Diameter, best wire size diameter we need to find. Best wire size diameter we need to find, guys. All right. Now let us see how to solve this question. I gave you one simple equation, guys. I gave you one simple equation. Did you remember? Did you remember? Right. Now, best wire size diameter is equal to best size wire diameter is equal to. So what is that? P by 2 secant theta by 2. Clear, everybody? P by 2 secant theta by 2. Right. Now here pitch is given in the problem. Pitch is given in the problem. P equal to 1.4 mm. But theta is a thread angle. Thread angle. So is it given in the problem? No. But here one clue is given. One clue is given. Right. It is a metric screw thread. It's a metric screw thread. Isn't it, guys? It isn't. Right. Now for metric screw thread, theta equal to 60 degrees. That you need to know. Okay. Right. So for metric threads, for metric thread, to thread angle is thread angle theta is equal to 60 degrees. Right now everything is given. Right now best wire size diameter dw, best wire size diameter is equal to, it is going to be a p by 2 secant theta by 2. Right, such that it is going to be a p 1.4 divided by 2. Here secant theta is 60 divided by 2. Right, such that 1.4 is divided by secant 30 degrees. Right now here I can write it is 1 by 4 divided by 2 into 1 by cos 30. I can write for simplification. Right, from here I can write it is 1.4 is divided by into 1 by root 3 by. Right now from here I can write it is 1.4 is divided by 2 divided by root 3. Right, such that 1.4 is divided by root 3. Right now let's calculate and let me know the answer, guys. Let's calculate and let me know the answer. I'll give you answer. Wait a minute. Right now here it is gonna be a 0.808 mm. Okay, 0.80 mm. Okay, right now here the best wire size is best wire size diameter is equal to, it is gonna be a 0.808 mm. Okay, great. Now let me write the question answer. Here answer is 0.808 mm. Okay, right. Now let us move for next question, guys. Now here, if you need to remember this formula so that it is easy to solve. Next question. Next question. During orthogonal turning operation, the cutting speed, feed, and depth of cut is given. So cutting speed 2 meters, V is given. Feed is given F, mm per revolution. Depth of cut is given D, 2 mm respectively. The specific cutting energy, neglecting effect of feed force on the total turning power, cutting or total cutting power. Now specific cutting energy 2 joule per mm cube is given. Now what we need to find? Main cutting force FC we need to find, right? This question we have been solved already, right? Now let us see, guys. Let us see. Now what is given? Cutting speed is given. It is gonna be a 2 meters per second. All right. Next, feed is given. It is gonna be a 0.2 mm per revolution, right? Now depth of cut is given 2 mm, right? Now specific cutting energy. Specific cutting G is equal to, it is going to be a 2 joule per mm. Now what we need to find? FC we need to find, right? Guys, here specific cutting energy, I gave you the formula, right? We have derived that also, right? Now specific cutting energy is equal to, cutting power. Cutting power is divided by, metal removal rate I gave you, right? Now here specific cutting energy is equal to cutting power FC into cutting velocity and metal removal rate, speed, feed into depth of cut, right? Now here specific cutting energy 2 joule per mm cube is given. 2 joule per mm cube is given. So now this one will get cancelled. This one will get cancelled. Now here it is given meters. Now we just multiply with a 1000. Just multiply with a 1000. That means here 1000 or else in simple you can 1000 will get cancel. You just multiply with a 1000, right? Now here I can write it is my FC is equal to, it is going to be a 2 into F into D into V is divided by FC into, oh my god, no, FC we have already know. Now it is going to be a, now here it is going to be a V will get cancelled. Now it is going to be a 2 into F is 0.2. F is 0.2. Now D is 2 mm such that it is going to be a 0.8, but multiply with a 1000 because speed is given in meters now. So it's that we are going to get it is a 800 newtons. Okay, 800 newtons is your answer. I hope you understand, guys. I hope you understand. Clear everybody? Clear everybody? Right. Now let us move to, so your answer is here. Your answer is cutting force FC is equal to, it is going to be a 800 newtons. Yes. Now let us move for another question. Let's have a look on this question, guys. Have a look on this question. So now have a look on this question. 59th question, 2 marks question. ECM, electrochemical machining process. Electrochemical machining performed, electrochemical machining performed on a flat copper workpiece. If the material removal rate is 2 centimeter cube per minute, 2 centimeter cube per minute throughout the process. Okay, now the required current we have to calculate. So now some specification is also given, right? Now I we need to find. So copper properties, melting point and density and gram atomic weight and valency dilution. Okay, next Faraday's constant, Boltzmann constant is also given. Clear, everybody? Now let us move for metal removal rate. I'll just write the given data so that we will segregate the question, right? Now here, metal removal rate is equal to, it is going to be a 2 centimeter cube per minute. 2 centimeter cube per minute. Next, density is given 9 gram per centimeter cube. All right. Next, atomic weight. Atomic weight, we have a 63. Now, valency, V is equal to, it is going to be a 2, right? Now, Faraday's constant. Faraday's constant, F is equal to 96,500 coulombs. 96,500 coulombs. Clear, everybody? Right. Now here we don't Stephen Boltzmann constant is not required and melting point is constant is also not required for the problem. So don't get afraid by watching this data. So what is given new? Nothing is new. Nothing is new, guys. Nothing is new because we have already discussed this one. We have already discussed this one, right? Now see metal removal rate in ECM process. Now let me write that formula. Metal removal rate in electrochemical machining process. Electrochemical machining process. We have derived this. Have a look on this. Okay, have a look on our note. What is that? What is that? So now here, I into A is divided by F into V into density. F into V into density. Right? Okay, guys. So try to write the formula. Then we will move forward. Yes, right. So all the given data is given, right? What is that? Current is given, atomic weight is given, valence is given, and also density also given. Faraday's constant is given, right? Now here it is going to be a metal removal rate is given in the problem. So 2 centimeter cube per minute. 2 centimeter cube per minute is given, right? Now it is I. We have to find out now atomic weight. Atomic weight is 63. Valency is 2. Sometimes I told you guys, whether you remember or not, I don't know. Sometimes you need to remember this Faraday's constant 96,500. You need to remember. Sometimes it is provided in the problem, but here it is provided in the problem. No problem at all, right? Now A equal to atomic weight of copper is 63. Faraday's constant 96,500 into valence is 2 and gram atomic weight, it is going to be a 9. It is going to be a 9. Now it is going to be a 9, right? Now just divide this fellow into mm cube per second. 2 divided by 6 such that you are going to get it as a centimeter cube per second, such that I into 63 is divided by 96,500 2 into 9, right? Now we need to find I. So I is equal to, it is going to be a 2 into 96,500 into 2 into 9, right? Now this is going to be a divided by, so 60 into 63. Now if you're able to solve this, then you're going to get it as a 919.04 amperes you will get. All right, 919.919.04 amperes you will get, guys, right? Now here, so it's a already we have solved this model. Okay, already we have solved this model. Already we have solved this model, right? Your answer is here. Your answer is here. So 919.04 amperes. Now your answer may be very, so 9152 921, something like that. Okay, no problem. Okay, all right, guys, I hope you understand. Guys, right? Now let us move for, right? Now that's all the questions have been solved. So have a look on this, go to this video and then try to solve the question. Clear everybody, guys? Clear everybody? Hope you understand. Right now let us so here I'm going to end the session.